This is Odum Maths. Today I want us to continue our discussion on the differentiation from the first principle. And we are looking at these two examples. So find from the first principles the derivative of the following functions. And the first one is f of x equals 5x squared minus 1 over x. Then the second one is f of x equals root x. So let's see how we can use the first principle to resolve or find the derivative of these two functions. So with the first one, I am going to let f of x be equal to 5x squared minus 1 over x. Okay, so in this case, my f of x plus h becomes 5 into x plus h squared minus 1 over x plus h, because I said earlier that for the f of x plus h, when we see x, we put x plus h there. Okay, so the formula is given as dy dx equals the limits as h approaches 0 of f of x plus h minus f of x all over h. So we are going to substitute this information into the formula. Okay, so the limits as h approaches 0, f of x plus h is now this one. So that is going to be 5 into x plus h squared minus 1 over x plus h, then minus this one. The f of x is this one. Let me put it in brackets. So 5x squared minus 1 over x all over h. Now I'm going to take the numerator and then simplify it. Then after I'll bring the formula, also put it here and then continue. Okay, so I have 5. I'm expanding this straight away. So 5 into brackets x squared plus h 2xh, 2xh, then plus h squared, then minus 1 over x plus h. Then here we have minus 5x squared plus 1 over x. Okay, so let me expand this. So I'm going to expand this, and that is going to give me 5x squared plus 10xh plus 5h squared, then minus 1 over x plus h minus 5x squared plus 1 over x. Okay, so here we can cancel these two. We can take care of these two. Okay, because 5x squared and then minus 5x squared can go off. Then again, let me rewrite this as 10xh plus 5h squared. Then I am going to bring this one here. So that is plus 1 over x minus 1 over x plus h. Okay. Then let me look at 1 plus 1 over x minus 1 over x plus h. I'm going to take this and then simplify this and then come and substitute it into where it's supposed to be. Okay. So 1 over x minus 1 over x plus h. So that is going to be, the LCM is x into brackets x plus h. Okay, so this into itself 1, or this will cancel this one, so this will be here. So that is x plus h, then minus this will cancel x plus h, so we'll get x minus x. So we have this and this being off. So we have x over, h over x into brackets x plus h. This, don't worry yourself expanding this one. You can leave it and then later you continue with it. So here, my 1 over x minus 1 over x plus h has given me h over x into brackets x plus h. So where I see 1 over x minus 1 over x plus h, I'm going to put this there straight away. So I have my dy dx equals the limits as h approaches 0 of 10xh plus 5h squared plus h over x into bracket x plus h all over h. So I'm going to divide each term here by h. So let me put this somewhere. So that is going to be 10xh over h plus 5h squared over h, then plus this is also going to be h over x into x plus h, also divided by h. Okay, so this is going to give me 10xh over h. I'll come back to this plus 5h squared over h plus, and this will be h over x into x plus h times 1 over h. Okay, that is the fraction rule. You turn this upside down and change this multiplication. Okay, so this will take care of this one. One of this will cancel one of this one. Then, so here we get h. Then this also take care of this one. So we have 10x plus 5h plus 1 over x into bracket x plus h. Okay, so this is what we have. Now let me bring the limits. So dy dx becomes 10x plus 5h plus 1 over x into bracket x plus h. Now, so my dy dx becomes the limits as h approaches 0 of this, of 10x plus 5h plus 1 over x into brackets x plus h. Okay, so as h approaches 0 means that when we see h, we can put 0 there. So we have 10x plus 5 into 0, then plus 1 over x into x plus 0. Okay, so this is going to be 10x, then this will go away, plus here we have x, 1 over x times x, because this is gone. So 1 over x times x is 1 over x squared. And we can rewrite the answer as this time, this multiplying becomes 10x cubed plus 1. So this and this will 10x cubed all over x squared, because the LCM is x squared. So this multiplying this becomes 10x cubed. Then this multiplying itself becomes 1, then all over x squared. Okay, so either this or this can be the answer. Now let's look at the second example. Okay, so let's look at this example also. Now here let's f of x has been so f of x is, now let's f of x plus h be root of x plus h. So it means my f of x plus h minus f of x becomes x plus h in this root minus root x. So now let's substitute this into the formula, and the formula is giving us dy dx equals the limits as h approaches 0. So of roots x plus h minus roots x all over h. Okay, so let's take the numerator and then resolve it or simplify it. Okay, so that is roots x plus h minus roots x. And in dealing with radicals, when you have something like this, all that you need to do is to multiply this whole thing by 1. And multiplying this by 1, we say that multiply this by the conjugates of this one. And when we talk of conjugates of this, that is, I'm going to multiply this whole thing by root of x plus h plus root of x. So this is the conjugate over root of x plus h plus roots x. So this is the conjugate. And when you divide this and this, you are going to get 1. So that is why I said you multiply this by 1. So the conjugate of this is this one. Now let's simplify. So the LCM is already this one. So I'm going to expand the numerator, and then after I'm going to substitute it here and continue. So this time, this is just like roots a times roots a, which is a. Okay, so that is just by the way. So this and this will be x plus h. Now this root x plus h times this one will be plus root x plus h times, so let me put it in brackets, times root x, then minus root x also by this one first, root x plus h, and then this and this one, when you multiply, that is going to be minus x all over x plus h, root x plus h plus root x. Sorry, yes, root x. Okay, so from here, this and this will go away. This one will cancel this. And then x and minus x also go away. So we'll get h over root of x plus h plus root x. So this is what we have currently. So let me substitute this into the formula, and the formula is dy dx equals the limit as h approaches 0 of this, that is h over root x plus h plus root x all over h, because this h, we shouldn't forget this h. Okay, so from here, this can be written as the limit as h approaches 0 of h over root x plus h plus root x divided by h. Okay, and still we can have this as the limit as h approaches 0 of h over root x plus h plus root x times 1 over h, so that this and this will go away. So we have the limits as h approaches 0 of 1 over root x plus h plus root x. Okay, now as h approaches 0, it means that when we see h, we can put 0 there. So that is going to be 1 over root x plus 0 plus root x. Okay, so here we have 1 over root x plus root x, and that is going to give us 1 over this, and this becomes 2 root x. Okay, so this is the answer to this. So this brings us to the end of this class. Now let's meet in the next lesson. Please don't forget to subscribe, like and share. Thanks for watching. Bye.